Hello retro fans! Today I'm going to show you how to assemble my FPGA adapters, which I have created to use in conjunction with the Ultimate 64 or the Reloaded MK2 board. And I'm going to chit-chat a little bit about the function as well as what's going to be important during the assembly process. And in order to jump right into the topic, let's move to the things itself. And as you can see, I have created basically 3 different adapters with different purposes, well, obviously. And we are going to start with the single FPGA twin socket adapter. So this adapter is meant to be used on boards like the Ultimate 64 or the Reloaded MK2, and the function is simply to get the second SID emulated by the FPGASID back to the board so that we have the full functionality of the built-in mixer of the Ultimate 64, for example, and to reduce the wiring on the Ultimate 64 for especially because there we have some limitations. And we're going to use the address change options of the Ultimate 64 to provide data to the second FPGA SID or the second SID emulated by the FPGA SID. So basically we are just going to need one cable and the others are not used anymore. And as the next thing, we're going to build this twin FPGA SID to twin socket adapter, which is basically, well, almost the same like this one, just with 2 sockets. But here we have to pay attention to especially the order of the assembly. And last but not least, we're going to talk a little bit about the so-called Mixsid replacement adapter, which I have basically built for myself because I have a couple of C64s where I want to exchange the Mixsid against the FPGASID. And I don't want to rewire the whole thing because I'm using this so-called modulator replacement. I have audio ins, and then I have this 3.5mm stereo jack at the rear of my C64, and then I can simply connect this to each other and everything is working fine without rewiring. So basically, let's jump right into the action, and we start, as I said, with the single version, and then we move on to the twin version. Basically I'm using most of the time my little assembly mount here because then everything stays in place and my life is a little bit easier. And basically here we have to pay attention that we solder this socket connector first because this is covered by the socket itself later on, and then it's pretty hard to get access to this, and therefore we're going to need 2 of those socket connector thingies. And since the SID has 28 pins, we need 14 on each side. And this is a little bit unfortunate, whatever we want to call this. It's a little bit, well, sad, because there's always some leftover material if we're going to cut this out of a 40-pin connector, for example. But if we're going to use a 20-pin connector, then it's probably even worse, because the pieces we got left are even shorter. And so I got these longer versions, which are pretty expensive here in Europe, so I got them from China. And this just as some background information. And I'm using most of the time a socket to keep all that stuff in place, and especially to have a proper alignment. And now we really have to pay attention that we put this into the right place. It's supposed to be here. And then we're going to solder the first row of pins or column, whatever we want to call it. And here it's really important that we have good alignment. First line is done, and before we go and solder the socket onto the board, we have to place additional pin here, and this is the so-called chip select signal from the second socket. And since this is blocked by the socket later on, we have to do it right now. And here I'm going to use my leftover material, and I simply just break out one of the pins here. Quite simple. Flip this around. And then we can simply solder it to the PCB. You have to pay attention that the alignment is correct and that we do not burn our fingers while holding it. And this is almost perfect. This looks even better. Here we go. So, and then as mentioned already, we can go and solder our socket. And basically I do it this way, that I get this off again, because then we have a little bit more space on especially the left hand side. And then if you can turn this around, place the socket into the designated space, and we have a chance to solder this side a little bit easier. And therefore it shouldn't be a problem at all. So the socket is done, and before we going to solder the remaining socket connector, we're going to solder one thing on this side. This is where we are going to connect our grabber to it to get the chip select signal from the second socket. And in case you may wonder how to use this and how to configure this on the Ultimate 64, there is going to be a special episode about FPGASIDs on the Ultimate 64, and then I'm going to explain all the nitty-gritty details, how to configure all the addresses, how to use this in combination with the Ultimate 64, and then I hope everything will be much easier to understand. And here it's going to be the same, just look for some nice alignment. Technically it doesn't matter, it just looks good, anything. So, and then the remaining socket connector. That's perhaps a little bit easier if we're going to turn this around again. So, not very complicated, and then we have to move on to this side where we're going to connect basically 4 pins which are used for the analog in, for the pedals for example, and for the external in for the SID signal. And one pin is for the second SID emulated by the FPGASID to bring the audio signal back to the second socket. And basically it was a learning. I should have placed 5 holes on the PCB so we could skip this step, but basically I haven't learned this after I've got this whole stuff. So we have to break away 1 pin from this 5-pin header, or you go and simply mount 2 pins to it, whatever you want. 2 pairs of 2 pins, so to say. But basically it works like this as well. And here we really have to pay attention that we have a good alignment, because this needs to fit into the second socket. And we could use a socket as well, but can do this by eye if you feel comfortable doing so. And then we simply solder those 4 points. And while we are here already, I can explain the reason for those solder pads here. So on the Ultimate 64 compared to the Reloaded MK2, the 2 SID sockets are swapped, so to say. So on the Ultimate 64 that's going to be the first one, and that's the second one. On the Reloaded MK2 it's vice versa, so that's the second one and that's the first one. And depending if we want to use the pedal function of the FPGASID, which is probably something that is not working on the Ultimate 64 because it had its own pedal system, so to say, we can decide from which socket we're going to get the analog signals. And there's a very small mark on it so that we know where's the first socket. And we simply have to solder this to the version we want to use. And let's build one for the Ultimate 64. Then we solder those pads, which are more pointed in my direction. And on the MK2 we would do it the other way. So basically there's just one thing left, and this is going to be the pogo pin. And this is indeed a little bit tricky, because here it is very important that we have a very good alignment of the pogo pin. These pins are very sensitive, so if we solder it in a wrong position, we cannot bend it to the correct position because it will break. So therefore it is really important that we get this right. And since I have to build a couple of those things, I got a blank PCB from Andy, the creator of the FPGASID, and I added some socket connectors because the height is very important as well. So we want to have some pressure on the pin when the FPGASID is installed, but not too much so that the FPGASID really fits into the socket, and therefore it's really important to get this right. And if you are not lucky enough to have something like this, then I can show you how we can do this with the FPGASID. It's not going to harm the FPGASID, so don't be afraid, as long as you're not going to solder this for the next 10 minutes or something like this, which is probably something the poker pin won't survive anyway. And I have done this at the beginning, that I just placed the FPGASID on the socket without any pressure. It's just that it is there, and then I turn the board around, let the poker pin slip through, and then basically most of the time it hits the designated point, which is this small solder pad here where my finger is pointing at. Quite right, and then we can solder it from the top. It has the disadvantage that we have to keep the FPGASID in place, otherwise it will just drop to the bottom. But for the sake of the exercise, I'm going to show you how this is done. So I'm using my ring finger to hold the FPGASID in place. I check twice whether the poker pin is aligned properly, and then I simply solder it to the PCB. And here we really have to pay attention that we're not going to move it while pushing the solder iron against the poker pin. And then we check it whether the alignment is correct, which is perhaps a little bit hard to see, but in real life it should be that much easier. And then everything looks fine. Last but not least, we can shorten the poker pin at the bottom a little bit. That's basically not a problem on the Ultimate 64 because there's enough space. It's right between the sockets. It's no issue, but on the Reloaded MK2 we have so-called zero insert force sockets, and they are kind of well, filled in the middle, and therefore the adapter won't fit. And here we have to pay attention that we do not shorten it too much, because there's a small spring inside and we need some room for the poker pin to slip in, and therefore if we just cut it just below the PCB, it won't move anymore. So my recommendation is to cut almost a half of it, and that's absolutely fine. Then we can check, it's still moving, everything is fine, and here we go. First adapter is ready to use. I recommend some cleaning with isopropanol to get rid of this plugs, and then it looks much better, and it is recommended because it can cause some corrosion as well. So then let's move on to the next one, which is a little bit bigger and a little bit trickier in some concerns, and it has more options, and therefore we really have to think what we're going to do with it. But basically it is not very complicated. So my learning is that especially the area here in the middle is a little bit tricky. So if we're going to solder all the connectors to the bottom of the PCB, it is a little bit tricky to get in between those connectors. So I did it in a way that very same procedure, using a socket for proper alignment. Then just turn it around, check twice that we have the right position. Just some tea. And then we're going to solder this one first, because this is covered by the socket later on. And it would be very uncomfortable to solder it to the board. So just to hold it in place, and then you can move on. And that's it for the first one. And then, as I said, I continue with the socket, because now we still have some space on this side. And as you can see, we may have to remove our interim, temporary, whatever, preliminary socket here to make space for the pins on this side. And same procedure, just keep it with your ring finger in place. Solder the first pins. Check whether the alignment is right. And then you can release it and complete the whole line of pins. Oh, it's going to be hot on my finger. So, first set almost done. So let's do it on the other side. And then I think we're going to have a deviation to the method I have used before, because I had some learning. So, and usually I solder the next a little bit off. Oh, no, appears to be okay. Usually I solder the next socket connector, but this causes the problem that it's going to be a little bit tricky to solder the pogo pin to it at the end of the day, or at the end of the process. So let's do it a little bit different now and solder the pogo pin right now. Basically, I did this at the end of the process because those pogo pins are very sensitive, they break very easily, and therefore it is recommended to pay attention to this little thingy. And here we're going to use my nice solder helping adapter. Check whether the alignment is right, looks good. And then you can solder it directly from here. And especially this one is very, very sensitive because, as you can see, there is not enough space, not a lot of space between the different pins here. And if you use too much solder material, it is quite likely that you create some kind of a short circuit here. And in order to avoid this, you really have to pay attention that everything looks fine. And then we can cut a small part of it already now. And then we can get rid of our helper PCB here. So I have to pay attention that we're not going to break any of those pins, which is probably not really a big issue for my PCB here, but for real FPGA it would be very, very uncomfortable. So, and now we're going to add the next one. And probably more comfortable this way. Same here as well. Do not shorten the pins. It's perhaps a little bit hard to see, especially if you have a soldering material including the flux. Then it creates some kind of well, contamination of on the PCB, which looks perhaps like we got it connected. So it makes sense to use a lens like this and to check whether this is fine or not. So as I said, it's a little bit hard to see, so if you are really in doubt, then you can use a voltmeter to check whether there is a connection or not. And basically those pins shouldn't have any contact to each other. And the same here. It's very sensitive, this area, because we got the main voltage on the very last pin here, and this is the audio out of the SID. And if you're going to shorten this, it's perhaps not very good for the FPGASID. It can stand it for a while, but I wouldn't recommend this. So, and then I go on and solder this socket connector, because this will leave some space for the connection here. So So everything looks perfect. And then I simply remove this again, because this provides a little bit more space for soldering the socket to the PCB if we do not have this socket connector here on this side. And basically we're not going to need this any longer, so let's just remove it. And then we go on with our socket here. Same procedure. Keep it with your finger in place. Solder the first pins. We can release it and go through the whole line. go. And there's just one left. Can be done quite quickly. Stays in place by itself. Just let's turn it around. That's for the socket connector and the sockets. Now we have to solder the remaining pogo pin to it. Oh, I got a broken one. Oh. And same procedure. Where's it? Here. Check for alignment. Everything looks good. Very nice. We can get rid of this again. We can shorten the pin a little bit. It's much easier from this side. There we go. And then we have just one or two things to do. I have included a so-called mixer options where the idea was to mix the two emulated FPGASIDs together. By using 1K resistors and then just bridging them and routing the audio back to the audio of the socket. But since the newest firmware release for the FPGASID, we don't need this any longer because the FPGASID has a mixer option now included. And this makes it much more comfortable because you can select whether you want it or not. And but in order to get some audio back to the board, we have to at least solder two pads here. Otherwise we won't have any audio on board, which is perhaps interesting if you're going to use the external audio options, which I'm going to explain quite shortly. But for now, we're going to have some onboard sound too. And therefore we really have simply to check twice, connect the pads here and here. So, and then basically that's all we have to do. Now the adapter is ready to use, except you want to use some external audio. Let's just turn it around and writing is correct. And basically we have three options here. We can use the solder points here to connect a cable, which is probably something like this. You connect 5 cables, 4 audio signals and 1 ground signal. And I have used the so-called mini DIN connector. A lot of people refer to this as a S-video connector. And we need the 6-pin version. There is no 5-pin version, therefore I've used the 6-pin version. And then we can use a cable which I have built for my purpose, which is a little bit short, therefore I can't extend this any longer. And then I got this audio signal transferred to my mixer. Or we can use this USB mini connector, which is the 5-pin version. That's very important. The so-called OTG version, because here we have 5 connections, 4 audio signals and 1 ground signal. And then we can use a 5-pin USB mini connector. It's very important. Most of them just have 4 pins. And then we can go through the antenna hole in our cases to get access to the audio. And this is indeed a little bit tricky. That's somewhere on my desk here. Because this is an SMD part and we have a very small gap between the pins here. So if we're going to solder this here, then we have to do all the 4 ground points, and then we really have to pay attention that we're not going to bridge the audio connections here on this little USB connector. For me, it's my preferred option because it does not require any drilling in the case or something like this, and I can use a very compact plug, and I get 2 audio cables easily attached to this little connector. And there is a small risk that you may use this by accident and connect a real USB cable to it. And if this USB cable is connected to a PC or a power supply or something like this, then you may add 5 volt to this board, which is perhaps not the best way to treat the FPGASID. It will stand this for a while, but I'm not going to recommend this, and I just recognized that I was a little bit shy with solder material here, so I may have to redo this later. And last but not least, the third option is to use the so-called GCT connector, and this can be added to this position here as well. And here we have basically one thing to pay attention to it. Basically, I had it in mind to do it this way, but I learned that this is going to interfere with the FPGASID in this position a little bit. So this is going to be quite tight to get the connector in. So depending on the case, especially on the C64 2 cases, I recommend this direction. But in the breadbin cases or in the PlexiLaser case, for example, we can turn it around, then we get a little bit more space towards the FPGASID, but we will need at least 1 mil more space on the case side. I'm going to show you this in a second. And therefore you really have to check whether this fits to your case and your way you have installed your Ultimate 64 board to your case. And before we going to complete this, I just briefly talk about the so-called Mixsid adapter. And I got one version already assembled. Here we go. Yes, so basically that's the very same procedure. We go to solder the socket connector first, then we place the socket on it, then we do the other socket connector, and at the end the poker pin. And then we got 2 jumper header connectors here. This one is for the connection to the modulator replacement. So we can connect this to this by using a so-called DuPont cables here. So that's just 2, we need 3, but they fit to these connectors very fine. And then we get the audio from the 2 emulated SIDs to our modulator replacement, and we can use the 3.5 millimeter stereo jack to get access to our audio signal. And then we have a second option, and here we can decide whether we want to have the audio from the FPGASID routed back to the board. And this is interesting if you really want to have the best quality possible out of your C64. Then I recommend to leave this open, because the audio routed back to the board may add some noise to your FPGASID signal on this connector. But if you want to have some sound on your board, then you simply put a jumper on it, or if you're absolutely sure that you won't have audio on your board, whatever is going to happen, then you can simply use a small wire to bridge this completely. So basically that's all about this one. And as promised, I'm just going to show you how this looks like in a case. So we have this Ultimate 64 built into a standard C64 2 case. And as mentioned, if we're going to add our adapter to the board, then it is very tight in this area. So I really had to change the PCB again to make it fit better here. Because during the development of the PCB, I never had the Ultimate 64 built into a case. It was on my desk all the time, and therefore I didn't recognize that this is going to be very tight. And if you're going to take this little connector and put it this way, then everything fits very fine. But if we're going to add, now it's gone. I was afraid of this. Somewhere, yeah. If we're going to add the other part of the connector to it, then it is going to be very, very tight, and we really have to place this very carefully that everything fits together. And the other way around would be to place it like this, but then it's going to be very tight. With the case here, it works, but it's perfect. It's not perfect. So I'm sorry for this, but basically this is very critical, because there is not enough space. I can't move the sockets anymore, because then I have problems with the socket connectors. I would have placed this on the other side, moved both sockets in this direction, but then I had a lot of problems with the wiring of the PCB. Therefore I decided to go this way. And last but not least, I'm just going to show you how it looks like when we're going to add this little USB connector here. And then you can see it is really perfect. And then we can use our little plug, put it through the hole, and got access to our audio signal. So basically that's all I have to say about the adapters so far. As mentioned already, there will be a special episode about how to configure all that things on the Ultimate 64 and FPGASIDs and how everything works together. And basically that's not topic of this kind of assembly episode, and therefore there will be another episode, as mentioned. If you have any question, if something is still open I haven't covered during this episode, feel free to use the comment section. Feel free to use Twitter, for example, where I quite active as well. Or if you are at the Forum 64, feel free to contact me over the Forum 64. That's no problem. And basically, as usual, thank you very much for watching. See you for the next episode, and bye bye.